Hello, my name is Jasper Smith. I am a product manager for the Bowtie XP and Incident XP software packages. During this video, I will discuss the possibilities of linking incident analysis diagrams with the Bowtie risk analysis diagram. To understand the relationship between Bowtie risk analysis and incident analysis, we need to take a step back and look at how they are related from a risk management perspective. This is a simplified representation of risk management, distinguishing three main stages: plan, do, and check or monitor. During the planning stage, the risk of a dangerous process will be analyzed proactively. Even before we execute our dangerous process, we can already identify ways of how to control it in order to avoid any negative consequences. The Bowtie methodology is one way of doing so. It provides a clear graphical representation of how we can lose control over our process, which consequences that may have, and what barriers we have in place to prevent this from happening. I will elaborate on these barriers later in the video. When we start executing our process, we move out of the planning stage and into the do stage. Here, the process is executed while taking the barriers into consideration which were identified during the planning stage. Unfortunately, no plan is perfect and every company will be faced with incidents from time to time. The incidents show us that our plan did not work as well as we thought it would. This might manifest itself in actual incidents or near hit or miss situations. Although incidents are always unwanted and possibly tragic in outcome, they also provide the opportunity to learn from what went wrong. Through analysis, it is possible to understand how the incident evolved and what causes lay at its root. With this new gained understanding, we can revisit our initial Bowtie diagram and make recommendations for its improvement. Incident analysis thus closes the loop of risk management by providing real-world feedback onto our initial risk analysis. The main message portrayed in this diagram is that incident analysis and risk analysis should not be seen as separate tools, but as part of a bigger risk management picture. In order to facilitate the link between risk analysis and incident analysis, both processes must be able to communicate with each other. They require a common language. This will be made possible by introducing the barrier concept, as commonly explained with James Reason's Swiss cheese metaphor. It starts with a hazard. Every company has hazards. They are not necessarily a bad thing, they are inherently present in every business. However, if the hazard is left unchecked, it will eventually lead to losses for the organization. An example of a hazard could be processing hydrocarbons under high pressure in a refinery. This is something an oil and gas company does as a normal part of business. However, if control over this process is lost, it can inflict various losses. Therefore, we must introduce controls or barriers to prevent the hazard from leading to losses. These controls can be technical in nature, such as a pressure safety valve, but also more behavioral or organizational, such as operating procedures or checklists. All barriers are designed and introduced to prevent the hazard from inflicting losses to the organization. Unfortunately, barriers are never as solid as presented here. No barrier is perfect. They will always have unintentional holes in them. In reality, the barriers would look more like slices of Swiss cheese. Some of these holes may have been present in the organization for numerous years. For example, a design flaw could have been made as early as 20 years ago. Other holes are made seconds before the disaster strikes, often by workers on the sharp end of the organization. For example, an operator might accidentally punch in the wrong number on the control board. Most of these holes are short-lived and may not always produce the losses because there are still other barriers in place that can deflect the hazard. However, if all holes in all barriers are lined in a straight line, the hazard can pass through and cause the losses. This is exactly what happens in an incident scenario. What is important to understand is that the barriers represent chunks of the safety management system that are designed to counter specific incident scenarios. This concept is used in both Bowtie and barrier-based incident analysis techniques, such as Tripod Beta and BSCAT. On the left side of the screen we see the bow tie diagram, which is used for risk analysis. It covers multiple hypothetical but realistic incident pathways. Bow ties can be constructed even before incidents have happened. On the right side, we see BSCAD and tripod beta models, which are both barrier-based incident analysis techniques. They represent one single incident sequence that has actually happened, and are always constructed after the fact. So, risk analysis and incident analysis are two different sides of the risk management picture, but they share the concept of the barrier, and this enables them to collaborate. Let's take a look at a bow tie example. Here, driving a car is our hazard, represented in the black and yellow box. It is part of our normal business, but it has the potential to cause us harm. The top event, the round orange shape, specifies the point in time in which we have lost control, or simply put, when we lose control over the car. Top events, of course, do not happen out of the blue. They are always caused by something. The blue threads on the left-hand side represent different plausible causes for losing control over the car. For example, slippery roads can cause us to lose control over the car. In the unfortunate event of having lost control over the car, multiple different outcomes are possible. They are represented in red consequence boxes. For example, losing control of the car may result in a vehicle rollover. Barriers can be placed on the threat and consequence lines. On the left side, they are designed to prevent the top event from happening in the first place, while on the right side, they try to prevent or mitigate the severity of the consequences. For example, ABS may prevent us from losing control in slippery road conditions, while rollover protection may reduce the damage and injury in case of a vehicle rollover. Therefore, when we look at a bow tie, we see a comprehensive graphical representation of plausible incident scenarios centered around one top event. One possible scenario is a driver distraction leading to a vehicle rollover, while another might be a blowout leading into a crash of deep water. So, incidents carve a path from the left side to the right side of the bow tie. In between, the path can be blocked by various barriers. But if they fail or do not apply to this incident, the incident will continue to evolve. This is similar to the hazard passing through the holes in the cheese. Another example. Suppose I am leading repair operations on a site and we use scaffolds to reach places which we cannot reach. Working at height is a hazard, so I may have created a bow tie on this topic even before I started the operation. For this example, we'll use a very simplistic one, covering only 3 threats and consequences, 3 barriers on either side. While we were making our repairs, one of our scaffolds shifted position, causing our worker to fall from height. Unfortunately, the worker involved broke his arm as a result. Now, we have already envisioned this scenario beforehand while constructing the bow tie. We know that this thread was active, which led to the fall, and ultimately led to the fracture. The question that arises is what happened with the barriers in between? Why did they not stop this event from happening? In order to find out, we can take the relevant thread and consequence arm out of the bow tie and use them as input for barrier-based incident analysis. On top, we see the bow tie, with the relevant pathway highlighted in red. We then move the pathway to the incident analysis diagram to take a closer look at it. While using barrier-based techniques such as tripod beta or BSCAD, we will uncover the underlying causes of the barrier failures. We can now use our understanding of the underlying causes to generate feasible recommendations to improve our barriers. After the barrier failure analysis is completed, we can feed the information back onto the bow tie diagram to see how our barriers failed in the context of the bow tie. But before we can go ahead and project the incident data on the bow tie, we must complete the incident analysis diagram and create a link to the bow tie diagram. Here we see a tripod analysis diagram which has identified 2 failed barriers: the use of adequately constructed scaffolds and the stabilizing of the arm with a splint. During the analysis process, it was uncovered that the scaffold was incorrectly installed due to the use of incorrect materials and that the first aid was not administered due to the lack of training. If we now go back to our initial bow tie, we will see that similar barriers had already been anticipated beforehand during the construction of the bowtie diagram. But we can see that the wording on the incident barriers and the bowtie barriers are a little bit different. This is because the barriers on the bowtie diagram are designed to counter many similar scenarios, and to be able to do so, they need to be more generic in nature to capture all possibilities. In an incident analysis diagram, however, it is the goal to be as specific as possible. This means that the barriers on an incident analysis diagram are often far more specifically defined compared to those on a bowtie. To bridge this gap, the investigator can interpret what the bowtie equivalents of the incident barriers are. For example, on the right side, we see the incident barrier stabilizing arm with emergency splint, which is equivalent to the bowtie's first aid and stabilization. The link between the incident feedback and bowtie diagram will be created in the software. This feedback can then be projected onto the bowtie and presented as an aggregated result of multiple incidents. For example, here we can see that the breath alcohol ignition interlock barrier has been implicated in 7 incidents, has failed 6 times, and was even missing once. The lane departure warning system, however, has been implicated in the same number of incidents but was effective 6 times. With this information in mind, we can reassess the quality of our barriers. So based on this realistic data, we might want to change our barrier effectiveness values. We have now given the breath alcohol ignition interlock barrier a very poor effectiveness, while we have given the lane departure warning system a good effectiveness, based on the feedback we received from the incidents. The end result is a bowtie diagram with realistic incident data, which looks like this. This particular bowtie shows 2 incidents presented in a single and concise bowtie. If more incidents will occur in the future, they can be represented on the diagram as well. This will only enhance the amount of information that is available to me. With the help of incident data, the organization may have to decide to improve a barrier that has been failing frequently, or perhaps the organization will want to invest in introducing an additional barrier. It can even be possible that an incident will point out a new threat to us that had never been anticipated before. With that knowledge at hand, we can improve our safety management system as a whole, not focusing on the outcomes of a single incident, but by taking all incidents into consideration. This can help us decide which problem requires our attention the most. For example, here we can see a recommendation presented by a yellow post-it note on the first aid and stabilization barrier. We recommend on including the handling of fractures during the first aid training to improve the quality of this barrier. All in all, linking incident analysis diagrams with bowtie risk analysis diagrams provides a clear overview of how the barriers in the organization are working. Instead of treating incidents as single cases, they can now be portrayed in a larger risk management picture by combining multiple incidents in one graphical bowtie. By linking incident data to bowties with Incident XP, a company will not only be able to represent how they are planning to deal with the risks, but also provide feedback on how well the plan is doing its job. And if there are flaws, we can easily spot them and make recommendations for improvement.